Today we are going to solve the question number 12. In question number 12, it is asked a spin half system is known to be in an eigenstate of s dot n cap with eigenvalues h cut by 2, where n cap is a unit vector lying in the xz plane that makes an angle gamma with the positive x-axis. Now it is asked a suppose sx is measured, what is the probability of getting plus h cut by 2 of that measurement? And second, in the second part of the question it is asked evaluate the dispersion in sx, that is sx minus sx square, its average, that is the dispersion. Now now check your answer for a special case gamma equal to 0, pi by 2 and pi. So let's solve this question. Now first we know that the eigenstate of an operator is dot n cap, where this n cap, this unit normal unit vector, is as follows: x, y, z. The angle between z and n cap is beta, and if we project this vector on the xy plane, the projection will make an angle alpha. It is, we see in the previous problem that the eigenstate of this operator is equal to cos beta by 2 plus sin beta by 2 e to the power I alpha minus. Now in the question 12 it is told that the n cap is a unit vector lying on the xz plane, that means in that plane. That means here alpha equal to 0, and what is the value of beta? Beta equal to here, it means alpha equal to 0 and beta is equal to gamma. Beta is equal to gamma. So in this question, what is the eigenstate of the operator s dot n cap? It is cos beta, beta will be gamma, that means cos gamma by 2, that means cos gamma by 2 plus bra plus ket plus sin beta by 2 minus ket, where these two kets are the eigenkets of the sz operator, eigenkets of the sz operator. Now it is asked if we measure sx, what we will get? From the previous question we know that if sx operator on plus half, it will give h cut by 2 minus sx minus k, h cut by 2 plus k. We are going to use these two relation. Now first question, what is the probability that getting h cut by 2? Now when we will get h cut by 2? If we measure by an observable sx, that is if the state is remaining the plus eigenkets of this operator, that means if it is remaining, if we write it in the same notation used in the question, h cap plus, that means if the state remains in this state, then the measurement will give h cut by 2. Now we know that the state is not in the state. State is in the state of cos gamma by 2 plus sine beta by 2. Here it is n cap plus. Now similar to this s dot n cap eigenvector of this s dot n cap, we can also write the eigenvector of this sx, because here for x, what is the angle? Here angle, it is given gamma. For an n cap which is along x, what will be the gamma? Gamma will be pi by 2. That means what is the eigenvector, eigengates or eigenvectors corresponding to this sx operator? That is 1 by root 2 plus, since sine pi by 4 equal to cos pi by 4 equal to 1 by root 2. Now we know that what is the probability that if we measure in this state and we get h cut by 2 as a result of measurement, that is n cap plus and x cap plus x square. It is the probability that we get h cut by 2 as a result of measurement, as a result of measurement by sx operator. That means it is, if we calculate this, what we will get? So let us first calculate what is the value of n cap plus s cap plus, that is cos gamma by 2 plus sine gamma by 2 minus, sorry, this will be bra plus minus, and this will be kate 1 by root 2 plus 1 by root 2 minus. From this orthonormal condition of this eigengates plus and half, we know that it will be cos gamma by 2, and this term will give 1, and this term will give 0. Similarly this term and this term will give 0, and this term give 1. That means we will get cos gamma by 2 plus sine gamma by 2. Now what is the probability? That means probability will be cos gamma by 2 plus sine gamma by 2 square, which will be cos square gamma by 2 plus sine square gamma by 2 plus 2 cos gamma by 2 sine gamma by 2. That is 1 plus sine gamma. This is the probability of measuring h cut by 2 if we measure with the operator sx. So we have done the first question. Now evaluate the dispersion. That means this relation. As we know, the dispersion is, similarly we can write dispersion in other terms. We can write dispersion is equal to sx square its expectation minus sx its expectation square. So first calculate the expectation value of sx in this state n cap plus. So sx cos gamma by 2 plus sine gamma by 2 minus, And if we use these two relation, that Sx operator on plus, it will give h cut by 2 and the state will become minus, and Sx operator on minus, state will give h cut by 2 and the state will become plus. So if we use these two relation, we will get this will be cos gamma by 2 minus plus sin gamma by 2 plus into h cut by 2. What is the then expectation? Expectation will be n cap plus Sx, n cap plus, what will be it? Let us calculate. That will be cos gamma by 2 plus sin gamma by 2 minus into cos gamma by 2 minus plus sin gamma by 2 plus. And from orthonormative relation, we know that if we from these two terms we will get 0, from these two terms we will get 1. That means we will get from first term that cos gamma by 2 sin gamma by 2, and similarly these two term will give 1 and these two term will give 0. That means we will get plus cos gamma by 2 sin gamma by 2, and here is an h cut which I have, means there is a h cut by 2, so that means it will become h cut by 2 2 cos gamma by 2 into sin gamma by 2, that means sin gamma. And what will be the value of Sx square? Its expectation, that means n cap plus Sx square its expectation. As we have seen from the previous problem, the value of Sx square is nothing but this, means h cut square by 4 into identity operator. If we use it, that means the expectation value of Sx square will be h cut square by 4. Then what will be the dispersion? Dispersion is h cut square by 4 minus h cut square by 4 into sin square gamma, that is h cut square by 4 into 1 minus sin square gamma, that is h cut square by 4 into cos square gamma. Now if we put the value of gamma equal to 0, that means we expect that if gamma equal to 0, then dispersion, if we measure Sx, the dispersion will be maximum. So let us check that. If we put gamma equal to 0, that then the dispersion will be maximum. That is h cut square by 4, and the dispersion becomes 0 when the state is an eigenstate of Sx. That means if n cap become s cap, that means then the gamma will be pi by 2. If gamma equal to pi by 2, that means dispersion will be minimum. The minimum dispersion will be 0. That is, these two have satisfied, and for an value pi by 2, there will be an intermediate dispersion. What will be that intermediate dispersion? That will be between h cut square by 4 and 0. What is this? H cut square by 4 into cos square pi by 2 will be 0. That I have calculated. Now the other thing is, what is the dispersion on pi? Again, for pi the dispersion will be again maximum, because it is in the direction of z, so then also the dispersion will be maximum. That means when pi, cos square pi means 1, that means again h cut square by 4. That means this this dispersion value satisfied our intuition. Now let us solve the question number now let us solve the question number 13, which is an interesting problem which is also related with previous problem. So let us solve this problem 13. Here it is asked, a beam of spin half atom goes through a series of Stern-Gauge experiments. A. The first measurements accepts Hz equal to h cut by 2 atoms and reject Hz equal to minus h cut by 2. And B. The second measurement accept Sn equal to h cut by 2 atoms and reject Sn equal to minus h cut by 2 atoms, where Sn is the eigenvalue of the operator S dot n cap. This eigenvalue problem of S dot n cap operator we have seen previously, and from previous 1-2 question we have seen that eigenvalue of the S dot n cap. We are going to use that S dot, the eigencase of this operator is cos gamma by 2 cos beta by 2 plus sin beta by 2 e to the power I alpha minus, we will use that. So, and with n cap making an angle beta with in the xz plane, that means here alpha equal to 0, that means the state will be eigenvalue, eigenvector or eigenkate will be cos beta by 2 plus sin beta by 2 minus. And in the question C, the third measurement accept Hz equal to minus h by 2 atoms and reject Hz equal to h cat by 2 atoms. What is the intensity of the final Hz equal to minus h cat by 2 beam when the Hz h cat by 2 beam surviving the first measurement is normalized to unity? How must we orient the second measurement apparatus if we are to maximize the intensity of the final Hz equal to minus h cat by 2? Here the experiment is first a beam of Ag atom whose spin will be in this case is sent to a Sg apparatus whose magnetic field is in the direction of n cap. Then we accept the state the all Ag atoms which are in parallel with the magnetic field and reject the Ag atoms whose spin will be in the opposite direction of this magnetic field. Then we will again send these atoms into a third Ag apparatus where the magnetic field is again in the z direction, and here we reject the all state which are opposite to the magnetic field, that means minus and accept only. Now we reject the all the state which are whose spin state is along in the magnetic field and accept all the state which are in opposite the magnetic field, that means z cap my plus. Now we are asked what is the intensity I2 here. If I0 intensity of Ag atom was sent into these Ag apparatus, then suppose I1 intensity will be out from this apparatus, and then these atom which are survive from this process will go through another Ag atom and then will send through Ag atom, and then we measure the intensity of what is the intensity of atom whose spin are in the opposite direction of the applied magnetic field. So let us calculate that. So first check what is the probability that after going through these SG apparatus, the AG atom will thrown into one of n cap plus, what is it? As we know that it is nothing but n cap plus z cap plus, and as we know that what is the n cap? N cap is cos beta by 2 plus sine beta by 2 minus, and z means plus, that is cos beta by 2. Then what is the probability that after coming as plus z cap after going through this SG apparatus whose magnetic field is in the direction n cap, after going through this SG apparatus, the state will be thrown into a state n cap plus, the probability will be e square, that means square of it, which will be cos square beta. And again, after going through this apparatus, what will be the probability that this state will be thrown into this state? The probability will be mod of n cap plus z cap minus square, which will be cos beta by 2 plus sine beta by 2 minus what it is nothing but sine square beta by 2. So what will be what is the intensity? That I1, then I1 will be I0 into, then I1 will be I0 into cos square beta by 2, and what will be I2? I2 will be I1 into sine square beta by 2, that means I0 cos square beta by 2 sine square beta by 2, which is I0 by 4 to sine beta by 2 cos beta by 2 square, which means I0 by 4 sine square beta. There, and in the last part of the question, it is asked, if we want to maximize the intensity of the SZ, the final SZ equal to minus h cut beam, then we have to for what value of beta I2 is maximum? If beta equal to pi by 2, that means then sine square beta will be 1. For beta equal to pi by 2, the intensity of I2 is maximum. That means if we set the SG apparatus or the magnetic field n cap in the direction of x cap, that means in the direction of x cap, here this is the z axis, this is the x axis. So if we n cap is here, n cap is beta, that means if beta equal to pi by 2, if n cap is in the direction of z x axis, the value of intensity of the atom of this Z minus will be maximum. So that is this. So thank you. Why it is so? Because the uncertainty will be maximum